Okay.
Hi, welcome. Welcome everybody.
Hi, Mika.
Hi
Thank you.
Rashbin, how are
Welcome,
you?
everyone. I'm good. How are you?
Fine, fine. It's
Good.
Thursday, another webinar.
Yeah.
It's
Here is a
been
bit hot in Germany, but the weather's going to get better next week.
okay. Yeah, how was your
How is it in Sweden?
vacation? Sorry. How was your vacation?
Sorry.
It's been
Oh,
a
it was
while
good.
since the last webinar, but I hope you
Yeah,
had a nice vacation.
it was great. It's
Yeah,
just enjoying the weather, and I hope next week it will be better.
yeah. Good.
And how are you doing? How is it
Yeah,
in Sweden?
good. It's good. It's cloudy as usual.
Howdy.
Not
Okay.
very cold yet, but I feel the winter is coming. So
Okay, already.
let's get
Okay.
prepared. Yeah.
Okay. So, what are we talking today?
Yeah, today is about building components.
Hmm.
So, as you know, before or during the summer, we did a new release of the app where we add
Okay.
new features in the component
Hmm.
editor. Kind of the
Okay.
guys kind of rearranged the component editor and other
Hmm.
new features and so on. I think it's
Okay.
good is we review the new
Okay.
component editor, and
Okay.
we also had a very nice feature related to CAD model or 3D model, both
Okay.
conversion and optimization, which will be covered as
Okay.
well during this webinar.
Okay.
And we will show at the end how all this goes together and
Hmm.
our recommendations how to build a component from scratch based on the 3D. But that will
Okay.
bring us to the academy course that you will present later,
Right.
uh, which is super important because building components is what is the is the is the biggest part in the Simumatik platform. I mean,
Right.
you build systems by putting components
Hmm.
together, but we need to build those components many times.
Yeah.
And how knowing how to do it is very important. There are a lot of features. The component editor is super powerful, but
Hmm.
in order to learn how to use it, we need a really powerful course, and this is what you are working on.
Yeah.
So we will be showing that. So
Okay.
basically, just a brief introduction to the news or new features in the component
Hmm.
editor. Then we will
Okay.
check the academic course you are working on.
Right. Hmm.
We will we will play a little bit with the new features in the component editor for importing and converting 3D models, and then
Right.
we will build a quite interesting component from scratch. Not completely, but we will show how you could approach the component creation. And
Okay.
that will
Before
be all.
before before we start, I just want to know from your opinion, what kind of skills someone should have to build a component?
What do you mean? What kind of
What kind of skills?
skills?
What kind
Yeah,
of,
yeah, yeah.
yeah, one should
So
need to
yeah,
build it?
I mean, it is important to have a basic 3D or CAD modeling skills because
Okay.
it's quite important to be able to play with the aspect, the 3D aspect or the visual aspect of the
Okay.
component.
Hmm.
Uh, it is important. Then, in many cases, the physics are super important. So you need to have a basic understanding of physics, kinematics,
Physics. Okay.
how constraints works
Hmm.
when you have a movable or a component that has movable parts, how you
Okay.
could define those movable parts. It's
Okay.
done through the constraints,
Hmm.
this link joint
Links and
approach we have.
joints.
Yeah, yeah.
Okay. Hmm. Okay.
And then, of course, the I would say the most important thing is usually the behavior, how you model uh, the component's behavior, and you do it using a Python script. So
Using Python. Okay.
yeah, the behavior can be super complex or very
Hmm.
simple, depending how you want to model this component.
Okay.
But it is important that you have basic knowledge of Python and you can somehow abstract yourself or this
Okay.
component to put it in a put its behavior in code. Okay, we will
Okay.
see a little bit of that today,
Hmm.
but the potential is huge. How you can combine the 3D aspect, the physics, and all other puzzle pieces, as we usually say in the component
Hmm.
editor, and then put the script, the Python script or the behavior to make everything come to life. And
Right.
it's kind
And
of
this
powerful.
Python is also included in the editor. You don't
Yeah.
have to have a separate Python.
No.
Great.
So we will
Cool.
see it now. Yeah. So yeah,
Let's have a look.
let's have a look. So I'm gonna start sharing my screen. Let's see here. Yeah. So I just log in with my John Doe account, the one we use to for the webinars. Also remember that even if we use the webinars to promote new features or talk about things you can do with Simumatik, it is we release these kind of banners now and then when we do a new feature release or whatever we do, and it's good to take a look. And here it actually talks about our latest release, how you can convert 3D models in different formats to GLB, which is the format we use in Simumatik for 3D, and do the optimization and so on. So even if it may take some time for us to build or to create a webinar, it's good to have an eye on the new features coming here for everyone and take a read. So you may find things that are super interesting that you otherwise you don't know what that we release. You can also follow us in our social media platforms.
On LinkedIn. Yeah. Cool.
Once you have read the news, you can close the banner, and it won't appear until we release a new or whatever, and then it will appear again. So don't worry, you can close it. Yeah. Yeah. So let's take a look to the component editor. So I'm gonna go to the public components, and let's. I think we discussed that we could use this cylinder with the section. Cut section. Yeah. So I could take this one. It's a public component. We just gonna open the editor to see how it looks like now. Okay. So it has been refreshed somehow. We use these tabs to jump between 4 different sections. So we have the details of the component, name, manufacturer if we want to add the real manufacturer. If it's a component that we just created and came up ourselves, we can just put our name. If it is as a known model, E-class, I think we mentioned it in another webinar, is a quite international component categorization system. So you can click on the link and try to find a E-class. This is quite interesting. In the future, we want to be able to search components by E-class. So for example, if you want push buttons or relays, you type the E-class. Even if someone hasn't called the component relay or push button, you would find them.
You will find it.
Yeah.
Great.
And then the description. Now we have more space and it's clear place for or box for the description. Yeah. You see who has created it. The last time it was modified. Here we have our colleague Aaron that this component. And then this is kind of the newest part, the assets manager or the assets tab. So what we have changed is that now you can see all the assets here together, or you can just filter them by
category.
Yeah. So we have the images where we include the thumbnail and the symbol. We have the script, which is the behavior Python script, and we have 3 models. If we will upload, if we will have a component that has plays some audio, or we add some PDF or whatever, those will be categorized in the specific part. Or if you have a zip file, for example, we do it sometimes.
The programs or
program or whatever. Yeah. So all assets here. Then it's easy also. Now you can select one or several, so you can download them all together. Yeah. But one of the nicest things here is that now when it comes to the 3D models, so if we can select 3D models when we have all the assets, but also here. Now we can click on one and we can open the 3D model. So we can have a preview of the 3D model. So this is one part of the component. Yeah, we can go back. We are going to open the base maybe. And what is cool here is that we see some stats as well. How complex is the 3D model? We see here in the right place, or right side, sorry, we see the different parts, and we can also select them here, and we can see which is each of the parts. So we see how all this has been built. Yeah. So you see the complexity in a tree format. You see the basic information of the position, rotation, and scale of the part. And this is super cool because we didn't have those stats before, but now we can see the dimension of the entire 3D model. The draw calls, we can mention it just very quickly, but the draw calls are how many calls the graphic card needs to print or to show or to visualize this model. Okay, it's kind of, in this case, is 6 calls to the graphic card to print or visualize this this 3D model, and then the complexity in numbers of triangles. Okay, so this we could say that number of triangles is less important than the draw calls. So you need to try to minimize the draw calls to the GPU or the graphic card in your models. Okay. So in this case,
and do you have any recommendation range? How much should be the draw calls?
Yeah.
Which is good
if you can have just one, that's the best. And we will see. We will see that we can get to that with some extra feature we have now in Simumatik. Okay. But in this case, is 6 draw calls. Okay. And each we can see that if we open another component, we will see that in this case, this is just a draw call.
It's one.
And
can you select 2 components and open together?
No.
When you were doing this selection?
No, I don't think so. I'm gonna check. I say no directly, but no. You see it. You see each file at a time. Yeah.
Okay.
Yeah. So that is one of the main things. The new editor.
That's very cool. Yeah. That's very nice.
We will see later that this editor is even more powerful because when you own the component, you can actually edit the 3D as well somehow. So we will see it later. Yeah. And you can carry out the optimization and conversion and so on. So, but just wanted to show for now, new feature, this new model viewer, okay? Or a model editor, we can call it. Yeah.
Okay.
And then we go to the old editor tab where we can see a preview of the component, how it looks like so far. Here we see all the different parts as before. Not much has changed here, but we have some extra buttons here. If you didn't realize, we have some buttons to allow seeing the locker elements and the sensor elements and also the lights. And just to show, I'm gonna add a light element here in the base link. So now here we have a light, and we can activate these elements so we can see. Now I'm gonna move a little bit the light, so we can see the position of the light. Okay, and how it affects the component. So now we see it's lighting the component here. Yeah.
Got it.
If we switch off this, it will still affect, but we don't see the position of the light source. Yeah.
And where can we use this light in the component?
You use it inside the base links, and it can be used to create components like light bubbles, or I don't know.
For the light
emitting
like LED lights. Yeah. Okay.
I mean, this is a quite powerful feature to add extra lighting to the scene through the components. But as usual, this is quite a kind of performance eating feature. So you have, from video games and so on, if you have a lot of light sources and you activate the shadows and so on, then it will become more complex. So here as well, you can activate if you want to cast the shadows from this light or not and so on. So it's kind of quite interesting. You could make this variable public, for example. So from the parameter panel in the workspace, you can activate or deactivate the casting shadows. I mean, you will get more realistic images in the workspace, or more realistic feeling, but it will take more resources from the computer.
Most engine. Okay.
So yeah,
cool.
That's that. And then I could say that here as well, the behavior editor, it has been improved. So now we have a bit more linting, we have colors and so on.
Okay.
Not many changes, but I think it's been a bit refreshed and we have some extra features for tabulation and
Okay.
supporting the programming.
Okay.
And I will say that that's all, because then the XML editor is basically the same. And as some of the viewers will know, you can also edit the component directly here. So at the end,
Okay.
a component in Simumatik is this XML and the assets. That's
Right.
the component. The editor, what we call the editor here, is another way of seeing what it is in the XML
Okay.
and the assets. Yeah.
So XML we can use too when we want to share the component features with someone else. We copy the code and send it to others.
Yeah, or maybe you
Something like
want
that.
to quickly copy paste something or duplicate
Okay.
something. You can do it
Duplicate
here.
something
We
with
don't
the
recommend to use the XML editor unless you are an expert user.
Okay.
And
Okay.
I think even ourselves, we use it less and less, but it's there just for transparency, so people understand as well. Okay, when I'm doing this is what happens, and so on.
Okay.
So, yeah. Then feedback button, super important. I think we always need to remember that the button exists here, is here, super available. Any issue, bug, question, or whatever is the best way to get in touch with us. You can just take a screenshot, mark something or whatever, and add us. This is in Swedish because it detects the regional language. Yeah, but you can send a feedback, and we try to answer as soon as possible. Yeah.
Great.
Yeah, and that's all. Clone buttons and all this as we had before. So let's go back to our
workspace and
let's see what we had next. So basically that was the component editor.
New features.
New features. Okay. So now I think that before we jump into playing a little bit more with the component editor, we should talk about the new academy, what's going on,
right?
What has happened the last months, and I think that is quite important that we talk about this new course that you are working pretty hard, and how important it is for us and for our users. So I'm gonna start sharing your screen. Let me see. So you can guide us a little bit. Yeah.
All right. So our academy, you can open up by going to academy.simumatik.com, and that's the main page. And if you go to the courses, we have several courses already public. So our recommendation is, if you're starting from the scratch, you start from this course, getting started with Simumatik. And then you can do the system builder and gateway integration. This is the course, how we develop in a sequence. And now the course which I'm working on is called Component Builder. And if you go inside this course I updated last week. So we have one section which is already public and others are coming soon. So what do you expect in this course? So I will be making video tutorials on how you can create your own component. And we categorize this component into different, we classify that into different category. One is like decorative component, where there is no physics involved. This is just to show, for example, your logo or some tools lying on the table or some warning signs. This has no physics involved and just 3D layout, or you can also build such component in the editor if it's just about box or something visual. Otherwise, you can import your 3D data and you can make this component. The second category is components without physics, but it has some behavior inside. For example, some buttons, and these buttons can give you electrical signal of 24 volts or 0 volts, or you can make some circuit breaker, which will break the connection between the source and the destination. And you can make a motor contactor, for example, to energize the motor. So it has some animation inside, which you can define with the Python script, which you were telling in the editor. And then next category is components with physics. These are a little bit more complex because there we include links and joints. And we also include some constraints and some collisions. So they have more impact on the physics. And in this case, the example is a conveyor. So this component can transfer the box from one location to another using some motion inside. And another example is some cylinders, which also has some physics, and it works on pneumatic force. So it has a little bit more complicacy. So once you're deciding which components you want to build, we recommend that you select based on where your component fits, which category a component fits, and then you can check out this particular topic. So our course curriculum is also divided based on this classification, like decorative components, basic components without physics, with physics, and we have several examples in that. Coming to the next one is sensoric. In this component, you will understand how you can make your own sensor, which is quite interesting because this will also have some physics involved because it will check the collision tags of the components that you have. And based on that, it can give you the signal if this component is, for example, metallic or non-metallic, or if it exists or does not exist. So such kind of components you will understand in sensoric. You can also create RFID component in which you can also write the data to your RFID tag using RFID read-write device. And then we have another category, which is mechatronic component, which you can see here. We have a robot and AGVs, which have multiple links and multiple joints, and it makes things more complicated.
Yeah, more complicated.
So we have already several components of this category in our library. You can anyways go on and check out how this has been developed by our developers. But if you want to create from scratch, then you can check out this course. Then the next category, which is very interesting, is smart components, because these components can interact with third-party devices using our communication drivers. So we have a lot of drivers in our gateway. For example, we have Siemens, we have OPCOA, Modbus. So imagine if you have a sensor and you want to read the signal from the sensor, not via voltage, but via Modbus. This you can do in smart components category. So you can create your own smart sensors. And if you are really interested in making smart components, you can also check our PLC, how we created our PLC. It's big, intense coding inside, but for sure you can do something similar. You can create your own PLCs as well. So that's how we categorize this course. So like I said,
one thing, just one thing. So at this point, I think it's quite clear, but just to be even more clear, that all components in Simumatik have been created using the component editor, even the PLCs and everything. So and the beauty as well is that you can always go to public components, open the editor, and see how they have been built. So there are two ways of learning: looking to components that already exist and trying to investigate or reverse engineer how someone has created. And this course will be huge complement to that. So you have a lot of components already, you can just check, but this course is gonna give you the guidelines how to approach if you are going to create different kind of components, which puzzle pieces are important for different categories.
And in this case, since we are building this course, feel free to write us your comments or feedback. If you have some specific component that you want to build, you can tell us. Maybe we can include that into the course. And this course is public now. Just feel free to register. You just need to sign up once, and then you have the access to our academy, and you can start learning right away. So, and this webinar, which we are recording today, we will also include into this course, so you can have an idea about what we are talking in this webinar.
Yeah, cool. And I believe as well that it's gonna be super helpful for you to get feedback. If people wants to get involved and give you comments and give us feedback about how is it going, the content of the course and so on, you will be really grateful. This would be on top of that, maybe you can give a brief description of what has happened the last months in the academy, because we have importing. I know that maybe some people is not being able to find the old courses now. But maybe you can just tell a little bit how it is organized.
So there was a lot of content we have to import, and we have to select which courses we have to import here. So if you're looking for, let's say, courses where you want to challenge yourself, now we have a separate course for this. For example, Simumatik challenges. So this we added here. And in this challenge, you will find some challenges here. So this I would recommend audience to try if you have gone through all the courses and now you want to test your skills. So all the challenges you will find here from basic to advanced. And if you think your topic is not covered in any of the course, so feel free to check our blog section. Oh, wait a second. This is...
I think it was
it's
the way
old.
to fix that. Yeah.
Okay, I need to fix that. Yeah. So in the blog, you will find several posts. For example, we have building an electropneumatic system, and if you go inside, you will find the full-length tutorial how you can build an electropneumatic system.
That will be the same as we had before. Yeah.
Yeah, this was the same content we had before. Yeah. I think my internet is a little bit slow. Anyway, so you have another category like building a component from scratch. So this is quite relatable to the content of this course, how we can build a component from scratch. And I think this is the video which you did in the last months or years. And basic hydraulics. So we don't have a hydraulic course, but we had this course in the old academy. So this is now in the blog. So once we make more content on hydraulics, we can make an individual course on that. So another was building a toy system. So here you will find several topics which you may not find in the course because we don't have a standalone course for that. Besides that, everything related to system builder you will find in this course, and gateway integration, which is very important because we are now categorizing individual courses based on the PLCs or based on the robots. So you can select here, let's say I want to work with Siemens PLC. So if I click on that, I will get inside to the course, and I just have to log in once, and then I will have access to my PLC course for Siemens. And there you will see the category. You have S7 1200 with OPCUA, with S7 PLC Sim. So you have one Siemens section where you have all the individual
different kind of integration.
Different kind of integration. Similarly, you have for Allen Bradley with Micro 850 or with simulator or with Logix controller 25000. So it has been categorized really good now based on what you want to learn. Yeah, let me just go back. Yeah, and then similarly, we're going to do the same for component builder, different types of component which you want to build. And this is the same course like from the last academy, build your own virtual lab. So same content is here. There's no changes in that. Pneumatics and electropneumatics is another course that we updated. So here you will find all the content related to electropneumatics and pneumatics. And for sure, there are also some challenges related to that. And yeah, that was all. Rest is just the challenges, and we're going to add more challenges as we progress with the course creation.
Right. Yeah.
And here is the list of webinars where you can find all the webinars from the last time. We have 8 webinars now. Today is the 9th webinar. We can update here as well.
Great. Okay, but then let's play a little bit, right?
Yeah. Right. Yeah.
Yeah. So I'm gonna share my screen again. Yeah, so let's go back to the component editor, and we are going to create a new component. So we were thinking about what we are going to build and so on. We wanted to show the potential of the conversion and optimization. So I was talking to the guys, and we end up that we have an Ender 3 printer here. So let's take this one and build a model of the printer.
3D printer.
Yeah, we are not going to create a complete model, but we are going to show how you could start building it, from scratch.
Okay.
So the guys found that there is this GitHub repository where you can download the step files of this printer. So I just downloaded it to my computer, and we are going to create a new component. So let's click here. We are going to call it Ender 3.
So one question, is it only that we need a step file? The extension of the file should be step file, or how is it?
I'm very bad in actually, step is kind of the standard for CAD.
Standard.
Yeah. But we don't like to work with the step because it's not that optimized for simulations and dynamic models. So a step, you can get a step file from any CAD program, CAD software, AutoCAD, SolidWorks, Onshape, or whatever you work with. You can export your CAD model into a step file, and now we can import it, but we will do some magic so it is easier to move it later. And this is what I'm gonna show. So now we could do that before, but now I can go here and I can download the step or upload. Sorry,
upload the step file.
The step file. Is kind of heavy, well, not very heavy, but 43 megabytes. It's okay. We cannot see it directly, and this is the first step. We need to convert it to GLB because GLB is the format we use. But now you can do it inside Simumatik. Before we had these tutorials, how to use Blender or how to export directly to GLB and so on.
Oh, that's cool.
Now we save all that time for you, and we offer the conversion in Simumatik. It uses the Simumatik credits. Okay. So if I click here, it will say, yeah, you need to have used 4 credits to do the conversion because we are using a service for doing this. It will save you a lot of time, or mainly if you don't have Blender or another middle software to convert from the CAD to GLB, it will do it. We can talk about the credits in a moment. So all organizations have some credits for free, and you can buy more credits. We are going to show it later. So if you want to convert it and save your time, you use the credits. So it's 4 credits for a conversion, and it will start the conversion. It's happening behind the scenes, and I will see here. We will get notified when the conversion is finished. It may take some seconds to minutes, depending how big the model is.
Got it. I have a question. So you said it converts to GLB file, right? If some user has already a GLB file which is optimized, he don't have to convert, right? He can.
No.
Okay, it's just an option.
Yeah, and we will show why, because now we are taking that step file, which has been developed to manufacture this printer. So it's a very detailed step file with all the screws and so on. A lot of parts, as we will see, a lot of draw calls, not optimized for our use. So now it's already we can open it, and we will see now. It will take some seconds to load because it's kind of complex, but it wasn't that bad. You see here the numbers. So this is almost 700 draw calls. So this is huge, and this is how it looks. It looks nice, but we have 2 issues here: 700 draw calls almost, and then over a million, almost 2 million triangles. It's a good, nice looking, very detailed model, but it's not what we want if we are going to build a component in Simumatik. Here we see all the structure, a lot of parts, very nice. We keep the structure in the step file, and so this is what we got now. The GLB file. So what I will do, and now what we are gonna do now is just create a component which will represent this 3D printer. I'm not going to add all the possible movements to the printer, but I was thinking that let's take the vertical movement, the vertical axis. So what we are gonna do now is that we have this GLB file. We could just remove this step file if we don't want. We don't need it anymore because we have it, but we can leave it there. I'm gonna open this, and before I do the optimization, I'm gonna split the model into 2 parts: the base part and the movable part. And because we have all the structure, that is a pretty easy exercise. So we are gonna click here, edit, and this is the new feature that we couldn't see in the first part of the webinar. So now here I can click different parts, and I can actually like move some parts. And if I want to kind of edit part of the component, I can just move, save, and that will be the new
Oh,
GLB file.
cool.
In this
Okay.
case, I just want to take the x-axis, and I
Mhm.
want to save everything but the x-axis. So I'm gonna bring
Okay.
the y-axis back.
Mhm.
Let's put it there. Doesn't matter that much. Yeah, we put the plate there. So I'm gonna save this as
Okay.
the base of the 3D printer. Okay.
But you also have Z-axis. Do you need Z-axis?
No, but for now we are gonna
That's
just
okay.
do that. I think
Okay.
X is actually our vertical axis, but it's called X.
Okay.
Yeah.
Okay.
So we have another issue. When we convert to a step to GLB, the scale was
Mhm.
in millimeters maybe, but it got it to meters. So this is
Okay.
a huge 400 meters
Yeah, it's a very
printer.
big one.
So
Okay.
if we can fix that as well. So we are gonna do two things. We are gonna fix the scale, and we are gonna
Oh,
type
okay.
here 0,
2.01.
0.1. Yeah.
Okay.
And if we fix this everywhere, now we can save this.
Mhm.
We are overwriting
Overwriting. Okay.
the 3D model.
Mhm.
Sorry, we are gonna overwrite it with another name. We are gonna call it
Okay.
the Ender 3 base.
Okay.
Okay. So now this will be just the base, and we are gonna do
Mhm.
another copy, but just with the x-axis. Okay, and we are
Okay.
gonna call this the vertical.
Okay.
So let's go
So in
back.
the last one, in the last one, you didn't have x-axis, and then you just created another x. So you split the component into
Yeah.
base and x-axis.
Yeah.
Okay.
So now I have two more. I have the original one.
Got it.
This should
Mhm.
look as the original one converted from a
Mhm.
step to GLB. Yeah.
Right.
And now on top of that, I have the base, which we
Mhm.
can see, and hopefully this one is smaller. Yeah, we see now
Oh,
is
cool.
40 centimeters.
Yeah.
We can fix the rotation, so we can take select here, or we can rotate 90
Okay.
degrees.
Mhm.
This is something that we were doing a lot in the editor
Yeah,
itself,
I
changing
know.
the origin. Now we don't have to do that. So I'm happy with
That's
it.
cool.
Just click save and overwrite. So I'm not creating
Okay.
another copy.
Okay.
And then I take the vertical, we open it. And now we can do the same. We edit, we can rotate it.
Mhm.
So it has the same orientation as the base.
Yeah. Yeah.
And on top of that, I was thinking that I'm gonna bring it down, so we have the origin
Okay. The origin.
down
Got
here.
it.
So let's take this and let's
Mhm.
move this down. So we have it somewhere there, and actually I can, we can leave it there. That's the visual
Okay.
aspect. So I'm not gonna make it super accurate now, just
I know what you
to
mean.
show.
Okay.
Yeah.
Mhm.
So now we could start building the component from those two models, but
Okay.
still, if you realize, sorry, I'm opening and closing all the time, we still have
No,
a
it's
lot
okay.
of draw calls here and
You're
a lot
right.
of triangles.
No
So
triangles.
this is not optimized, but we can do something. We can select those two files, click optimize, and we can do the next step. This is where we
Okay.
can do some magic. We have three different setups. We can focus more on performance, so we get less draw calls, less triangles, or we can select the other quality, focusing on quality. So we try to not modify that much the 3D aspect of the model. And we have the balance one. So we can just, let's go for this and use the credits. Doing this manually may take you hours. Now you do it just with a click. Of course, it takes you credits, but it's gonna take just some seconds. Yeah, it saves hours of work. Wow. So while these are getting prepared, we can go to the editor, and we are gonna add a link and a joint, as we usually do, just to add some elements for the printer. Okay. So the base will be
the base, which will be ready.
This we change the geometry, and we are gonna use a mesh. Yeah. And we do the same with the second mesh here. Sorry, here we select another mesh. Yeah. So now we need those two models So we can select here in the mesh model, we can select the proper file. They are still getting converted.
Okay.
And we already know that we want to have a vertical axis, so we can start fixing that. So we're gonna select here the axis is gonna be vertical, so we take theta, and we will set up the limits in a moment.
Limits. Yeah. Okay.
We can set the limits, how much it can move up and down, and we will also add some behavior because we are gonna make it. I was thinking, let's do something simple. Let's click on the element in the different parts and make it move up or down depending where we click.
Okay.
So we are gonna add as well the behavior element.
And
as you see, for the ones that are new with the component editor, at the end a component is basically adding these puzzle pieces we call that do or represent different aspects of the component. In the behavior you add code, but in the rest of the elements you don't add code, you just parameterize. Okay.
Right.
So let's, no, sorry. I want to check if, now we have the assets.
Okay. Cool.
Just to check what happened. So we know we had that kind of, we see already that the
6 megabytes,
the megabytes have been reduced. Let's see this one that had 400 draw calls, what happened with it, okay? So here we have one draw call.
That's cool.
Yeah, and the model looks pretty cool. So we didn't lose that much. Maybe we have lost some quality here. Yeah, you see.
Yeah, but that's not required.
But it's not a big issue. Okay.
Yeah.
So and you see here now it's a simple, very simple
one mesh.
One mesh, including everything. But we have different colors and it's been optimized for what we need. Okay. And probably the same with the other one. So now we can go to the editor and I had to save before.
You had to save it, yeah.
So I need to fix this again.
Okay.
So now let's go here. Let's select the mesh. And we can take now the model is going to be the base optimize. And now we go to the link. We don't see it yet because we have another mesh here.
Okay.
And we can add here
the mesh again. Okay.
The vertical optimize. Yeah. So now the only thing I need to do to get something, actually, you see it looks pretty cool.
Yeah, it looks very nice.
Yeah. We keep the colors and everything, but we just simplify the model. So we can just bring it up a little bit.
Okay, so this has to move up and down in the end.
Yeah, this is what we will make move up and down. It's perfectly aligned, so it's in place. And what we can do is that we can limit the joint, so it's gonna move. Let's see. If we take this on the link, we can move to, let's say, 10 centimeters down. And then from the 25 position we have it, let's move it 15 centimeters up. So we will set the limits. We will set it in this position, and then we will allow moving 0.1 negative lower limit, and we will allow it moving 0.1 0.15 up. Okay, that will be what we will allow the movement of this joint. Now we can save it, and I think I can add the logic right away with the behavior.
That was it. That was all.
That was the configuration. Yeah. So now.
Yeah, I mean the configuration. Wow, that was quick.
So if we want to make it move, now we have different options. What I was thinking is that we can use these user actions in the visual. So when we click in the base, we will get this activated, and then when we click in the link, which is the vertical axis, we will get this variable activated. So we can use this to make it move up and down. Okay, how you do that? We will have a really nice course about that soon. But so far, you can add a joint motor, which will help you to command this joint. Okay. So make sure we have the vertical axis here. Yeah.
Okay.
That's okay. And now again, here in the joint motor, we can select if we want to control the joint in velocity or position. We are going for velocity right now.
Velocity. Okay.
We select also the vertical axis. Okay. And what we need to change is this value. This is going to be the velocity
motor
set
value.
point for the motor. Okay. So basically what we need, we go to the behavior and we need to introduce the both click signals. So we are going to add a variable here and we are going to call it base click or click base. Okay, this is going to be a Boolean because we are going to connect this to the base link user action. And it's going to be an input.
Okay.
So now we are going to add another variable and we are going to call it vertical click or click vertical.
Okay.
And it's going to be as well a Boolean input for our script. And in this case, we are going to connect this user action. Yeah.
Okay.
And now the only thing we need to add is a variable to connect,
output.
In this case, an output.
Right.
To connect to this value here.
Joint motor.
So if you don't know which kind of variable is this, you can click here and it says it's a float.
Okay.
Yeah. So value, it should be a float and it should be in this, if it's a linear meters per second or if it's a rotational joint, radians per second. So yeah, then we go back here, we call it axis velocity or something like that. Oh, sorry, I think I changed the name to the this should be the output and this should be the input. I changed. No, we have two inputs and one output.
Okay.
And the output we need to change to float. Yeah.
Okay.
It will have a zero value in the beginning, but now we can take this and we can connect to our joint motor. So we can take this value and we connect it here. Yeah.
Okay.
So now we just need simple logic. Let's say in the beginning of each time we reset or we load the component, we just want to set the speed to 0, velocity to 0.
Okay.
And then depending what we click, we want to set a positive velocity or negative velocity.
Okay.
So I can do a very simple if statement. We do like this, and we can type axis velocity equal to 0.1, for example, or maybe less, 5 centimeters per second. Yeah.
Okay.
Up. Or if we click the vertical, then we want to have a negative speed. So velocity will be minus 0.05, for example.
Okay.
And if we don't click any of those, we want the axis to stop.
And they get 0.
So we just type velocity equal to 0.0, for example. So with this, we have a script, very simple script. We save the component. Yeah.
Okay.
And we can actually create a thumbnail to it. Yeah. So you can create a thumbnail from this page or directly from the editor. Okay. So let's take a nice view for it, and we can click here. We can zoom a little bit, like this, or maybe less, and we save. Yeah. And this picture is the one that we will see here. Yeah. So now we are happy with with our component. We could of course add some comments here, but we will jump on that. Yeah. So now we didn't even open a workspace. We just went directly to the components and create a component. But let's start a component, the workspace, sorry, and just test what we did. Okay.
Okay.
So we have seen so far how you can start with a step file and end up building a component that hopefully does something. Okay. So we are gonna call this system test and ender 3. And we just need to add an assembly. Yeah. And then we go to the component browser and we check our components and we filter here by ender 3. So we should have the component here.
Okay.
And we add it. So here we are. We have the component, and in just a few seconds it will appear. Yeah.
Wow.
So this is our new component.
Mhm.
Now we can see, yeah, it looks
very
pretty
good.
good. Yeah.
Very nice quality.
Yeah, the
Okay.
buttons, the switch. I mean, you could, if you would like, you could actually take this
Yeah,
part before you put
true.
all the base together, have the button animated and all this stuff. But
Okay.
it's been optimized a lot. So we can save this now, and we can check what happens if we click play. So if I click here, yeah, if I click here, it goes
Wow.
up, and if I click here, it goes down, and it should stop
Wow.
within the limits. So
At the
yeah, it
limits.
stops there. If I did it properly, yeah, it's
Mhm.
cool.
Can we make this variable public and see the values on the right side? That would be nice to see.
Yeah. So now
That
we
was
can
so
just
cool.
reset, and we can just come here, change the component editor, and we could say, okay,
Mhm.
let's make velocity
There's the
public,
velocity.
so we
Mhm.
can see the velocity, for example.
And maybe the position we can also see, right?
Yeah.
Can we see the position?
Then we need to add the sensor. But let's
sensor.
let's
Oh,
show
okay.
this, and then we have some
Okay.
we have some time. You see now we went back after editing the component that it says if we want to
Yeah.
reload the system. So now
Mhm.
if we click here, we see the velocity. If I click play,
Perfect.
I press here, velocity is positive.
Nice.
If I click here, velocity is
Nice.
negative. Yeah. If we would like to see the actual position, we can go back to the component just to show more features of
Yeah, that
the
would be cool.
joints. We can add what is called a joint sensor.
Joint sensor is called. Okay.
And basically, because a joint can have more than 1 degree of freedom. Here we could add more than 1 degree of freedom if we would like to move it in x-axis or whatever. You need to tell both the motor and the sensor. You need to tell which axis they will be measuring or acting on. So here we need to say we want to sense the Z axis. We want to sense the position at the rate 0.1 is good. Let's enable it. It's true. So here basically we have the value. We could make this public directly if we don't want to use it for anything in the behavior. Save, and hopefully if we go back, we reload. Now when we click here, we should see both the value. Of course, the name is not good, but this is the value of the sensor. And now when we go up or down, we see the position in meters.
That's very cool.
So
this is so useful to take a feedback from the linear drives.
Yeah. So it stop in minus 0.1, and it should stop in the top level. It's 0.15. Yeah.
So basically, it's a kind of encoder feedback, or maybe a scaled feedback from encoder. Cool.
So that was the component, and again, it's not the complete 3D printer. We could, this could be a smart component if you want to use connect it to some controller that is going to move its axis and so on. You could do a pretty cool virtual 3D printer and program it with Python, or I don't know.
Or you can connect a PLC next to it and just connect to the axis, motor axis.
In this case, we are commanding the axis with velocity, but you could command them in position. So you will have very accurate position of this.
So the ideal way is we energize the motor, and that will move the axis. Like this, would you do it?
That will be a one way. Depending what you are looking for. If you want to test the mechatronics of the printer, then you want to have all the elements, the motor with the step motor with encoder and so on. But if you just want to animate the printer doing something, then you could just take the actual position and command each of the axes with the position instead.
And we can also program in the Python if I just need to animate it, go up and down after some delay, up and down. So this I can do in the Python as well. I don't need to click user action or something. Cool.
So
very nice.
Yeah, so I think that was brief.
And there was it another feature that once you optimize the component, you can download the whole workspace or something like that? Or is this you can download both components now after it is optimized?
Now we have the component, we have the 3D models here. So actually now in the assets, I could remove all. I could remove this one, and this one. because the only ones I'm interested on is this and this. Yeah.
So these I can also download and use it later on somewhere else if I want, after optimization, after using the credits.
Those ones you can download, and actually we could open the online GLB viewer. Yeah. ULTF viewer. I think we have this one. Is quite good. Yeah. I think we use this one usually. Yeah. So we can just let me see what yeah, we can take this one, optimize, and we see what we actually optimize with Simumatik. Yeah. So this is the model optimized, and we can see here I think here we can see the draw calls, the stats, and so on as well. And it's the same as in Simumatik.
Okay. So I want to understand, if someone is not having an organization, it's an individual user, what are the credit system? How can he buy credits? How can he use credits?
Yeah, so I wanted to finish with that, because we have in the organization, we have, if you are admin, you will have this this tab here, which will show you who is using the credits, and we will see probably here John Doe has been playing around and has done some optimization and conversions. You can see here how many credits you had included in your subscription, which is your balance, and so on. If you want to purchase more credits, here you see is 400 credits is 100 euros. So each optimization is basically €1.
That's not much. That's very cheap.
No, I mean, it's a very good price. Taking into account all the work you are saving is not much.
It's very good price. I mean, that's great. Okay.
So,
but can someone buy more credits?
Yeah.
Just credits? It's also possible.
So you just contact us to order.simumatik.com and we can fix. So we send you a link to purchase the credits, and then you can pay with credit card or send you an invoice.
But if it's an individual user, can he also have credits when he buys a subscription? Okay. It's all possible.
Yeah, if you have a paid subscription, then you have some credits included every month, and then you can purchase more. Yeah.
Okay. No, that's perfect.
And also important to know that the credits, they do not expire. So you buy them and then you get them, and even if you are buying credits regularly, the ones that you are not using, they will just remain in your balance.
Okay, credit balance. Oh, that's perfect.
Even for organizations that get extra credits every year, they remain in the balance. Yeah.
Okay.
So let's see if we forgot something. So let's go back to our first slide. I think, let's see, we discussed about the features in the component editor, the academy, the new courses, the optimization process. Again, it was not the most complex CAD file, but we could see a lot of triangles, a lot of draw calls, which is affects the performance a lot, and how we fix that very easily with the optimization. And then quickly, very briefly, how you should approach the component creation. And this is what we do, and our team is doing all the time. We start with the CAD model, convert them, optimize them, and then we split different parts that are movable in that component and start bringing them to life. In this case, it was not a complex. What I wanted to achieve wasn't very complex, like in this cylinder we are seeing in the presentation.
Yeah.
But just from there is just building with more puzzle pieces. If you want to have a light, if you want to have a communication driver or whatever. So
this I will cover in the course.
Yeah, that will be covered. But that's the approach, okay? To identify which kind of component you are building, start with the CAD, and then with help of your course, you will end up focusing on some puzzle pieces that are interesting for you. How you, in this case, the joint motors and so on. Yeah.
Okay. Cool. That was very, very useful for me. A lot of new things to learn as well, because I was using, actually, I don't know if I should mention it, but another company for doing the 3D modeling, and there it was very, very complex compared to what you did today. I had to deal with a lot of physics and a lot of codes, although it was also in Python. But here, I think it's much more easier to build a component from scratch. I'm very impressed.
And I think now with the editor features to import CAD, there are more formats. You can check the news in in our I think we have
new
it.
section.
Yeah,
We have a
it
new
was
section.
here. Yeah, so I think it was not just GLBs, but we can take also 3D models, 3D formats. I think it's OBJ,
Okay.
Collada, STL. So we can,
Okay.
you can open a lot of models and then convert them to GLB directly in Simumatik. So it's for the
Okay.
cast you need to pay credits, but some of
Yeah.
the other formats we can deal with directly.
Okay. No, that's cool. So any other new feature which are in pipeline for component editor or component builder, which will be helpful?
Yeah, next in the coming week, we are releasing a lot of bug fixes in a patch. So it's gonna be, we know about some issues that been around, but the focus in the coming months will be the workspace. We are gonna have a new workspace engine, and we are gonna work quite hard with the workspace optimization for 3D rendering and so on. So we want to optimize the experience. We are gonna be working in VR with the VR as well. So
with VR,
it will be more focused on that. We are quite happy with the editor.
Wow.
So now it's gonna be more focused in the workspace.
So would there be a webinar with VR? Because I also have glasses here. You can do it something.
We will need to have one during the autumn. Yeah.
Okay, that's cool. I'm looking forward to that. And the next webinar, we are planning for, I believe, Ethernet IP driver.
Yeah, so it's gonna be gateway oriented, and yeah, and we have a new driver. It's called Ethernet IP, generic Ethernet IP or something like that,
right?
Or generic or Ethernet IP device. Basically, with this kind of driver, this is a new kind of driver. We can emulate the entire device, so it's gonna emulate even the IP address of this remote I/O device.
Okay.
So from the PLC perspective, we kind of make the PLC believe it's gonna be connected to real hardware.
Oh, wow.
And it works pretty cool, pretty well.
Cool.
It's Ethernet IP is compatible with many brands, so they use it a lot with Rockwell. We have been playing it around with Codesys, Yaskawa, and there are, I think, even Bekov you can connect pretty easily. So we will show different brands of PLC connecting to these emulated I/O devices, Ethernet IP devices, and how quick the driver is and how interesting. Yeah.
Well, that's
so that
very
will be the next one. Yeah.
So I would say stay tuned to our LinkedIn page for more notification, and I'm gonna upload this webinar into the course for others to view. And for anyone who want to get into Simumatik, book a demo, go to simumatik.com, and you can contact us anytime.
Yeah. Good, great. I think it was a nice webinar. Hopefully we get some comments. Yeah, give us some thumbs up and write comments in the YouTube channel.
Yeah.
And see you soon. Hopefully we have in 1 or 2 weeks we have another webinar. Yeah.
All right.
Good.
See you then.
Yeah. Have a nice weekend. Bye-bye.
You too. Bye. So I end the stream.
You know what we forgot? Start recording.
Wait a second. It's still not